Alright guys, welcome back to my nasty cluttered shop where we're going to be working on the Mustang engine tonight. So I think when I last left off, I'm just not real happy with the finish on this deck. The more I got to looking at it, and I think this camera will probably show it better. It has a sheen to it, but you can see the lines in it. Let's see if I can look straight down. And it's actually where you've got a pretty wide high spot, a real narrow deep spot, and then wide narrow, so that I can drag my nail across it this way, it feels rough. Drag it across that way, it actually feels smoother. So that actually does, depending on direction of machining, that certain directions will feel smoother than others. So with the previous copperhead gaskets, I wouldn't even be worried. I thought about reusing these. I thought about just using a little wheel, cleaning these up, spraying some spray a gasket on them, and going, and maybe doing a little bit of RTV around some of the stuff. This was back when I was pushing 20 pounds of boost when I ran these. I didn't want to have any blown head gasket problems, so I went copper. I did experience some problems where they wanted to weep a little bit of oil, especially if it sat for a long time, and this car does tend to sit, as it's been sitting for 2 years. So I want to go back MLS. And this is truthfully, I got lucky when I ordered these. I wasn't even thinking about it. But these are the Permatorque MLS from Fel-Pro. So on the back of the box here, it'll tell you what the surface finish requirements are for the installation. So an RA of 30 to 50, this is more like your old school machining. Granted, old school machining can get up to 100. RMAX 700, RZ 500. So these are the blue Fel-Pros for more of a retrofit fix, where somebody at an older machine shop with maybe not the best equipment can't hit a 30 to 15 RA or 20 to 15, which is I think what Ford would like to see. I think the Ford spec gaskets are 30 and below. This might meet an RA of 50. I kind of doubt it, but the reason I say it might meet an RA of 50 is that you've got a pretty wide high spot sitting there, and then a real shallow deep spot, or a real narrow deep spot. So when you average out over a length, it might not be that bad. Now RZ, I'm not sure what it would hit on the RZ, which is the depth of that lowest from highest to lowest point. I think that might be RT, I can't remember. Either way, I don't have a surface profilometer. I deal with machining surfaces enough to know that I really don't need one. I know this is borderline at best, and even if I had a profilometer tell me, hey, I'm right on the border, I'm probably still going to try to do something to address it. So I'm going to try to basically hand lap this thing in with sandpaper. You can see Old School Funk. There's a channel on YouTube. That guy does it with a big thick piece of wood, melamine, I think. That he's got some straight edges that he shows he's got a qualified piece of wood with a straight edge. That's all you need. You need just a good flat surface to be able to put a piece of sandpaper onto and just lightly sand this thing in multiple directions. And as long as you're going in multiple directions, you will be able to maintain a flat surface and knock down any high spots. You might think that's archaic and crazy, but actually the best surfaces are ground or lapped. Truly precision surfaces are not machined. Machining requires a tool bit to cut material away. That requires a lot of force. And you'll see deflections in the tool bits. Even as you go from, say, this piece of material right here doesn't have support underneath it. Some of these pieces don't either. Where you've got a solid, this wall goes all the way down. This is more solid. It will not deflect as far as like this little centerpiece here. So even at a level on a block like this, yes, the block is very rigid, but there are parts of this head deck surface that are not as rigid as other parts. So that tool bit is actually moving up and down through deflection. And granted, it's very minimal, unperceptible almost to a straight edge or anything else, but that is happening. Most people don't think steel flexes. Steel flexes actually quite a lot. You really see it in big, long spans. So in the end, highly precision surfaces are rarely machined. Yes, you can machine a block deck surface, and it is precise enough for the ceiling gaskets that we use. But just because you're sanding it doesn't mean you're screwing that up. You can actually sand something in more precise than the machining center could actually put it in. So as long as you've got a good flat qualified surface, this is a good qualified ground plate. Granted, this side of it, for some reason, I got out of a machine shop, but for some reason they had tape and plastic stuck to this thing. It really rusted in here in the shop, but the other side is actually in good shape. So I've got a good qualified flat surface. You could use melamine like an old school funk. I've also got a big block of plastic here that's really flat and pretty precise as well. So as long as you've got a good qualified straight edge that you can check and make sure this thing's flat in multiple directions, you're okay. And I've got the tools to do that, and I've already qualified that the bottom of this surface is going to be as flat as this deck. So, and even if it's not perfectly flat, as long as you're going in multiple directions, angular, fore, aft, you won't sand in a low spot anywhere. So now using like a rotary tool, like a Rolox or a flat disc or something like that, you can definitely sand in some low spots, concentrated, and cause yourself some problems. So for this, I've plugged my oil holes. This one I taped. I had a hard time getting this stuff to stick, this painter's tape. It did not want to stick to these cylinder walls and this piston. This one here, I've got an oil control ring sitting in here. This one's got good tension. I've got an oil control ring down in here, a paper towel, and this old piston sitting in there, and I've got an oil control ring down in here as well. And I just put a paper towel in there for a little extra protection. So when I'm done sanding, I'll pull all this stuff out. I'll roll the block upside down, blow out all my head bolt holes. I'm not real worried about that because I use studs, so I don't really, this part doesn't get torqued into these threads real hard anyway, so it's not going to mess up my torquing. And then I'll blow out the water jackets as well. So I'm going to stop right there and just show you a couple of things. And something like this will show it too. You can see that there are definitely high spots and low spots even in this machining. Again, this is just my first few passes going a long ways, and I'm uncovering differences. Again, these are differences in stiffness. that you're actually seeing of the block. So this just goes to show you, yes, I could have put a straight edge on it. You won't hardly see any light through these things. You could have maybe stuck a feeler gauge, a half thou under some of these areas, but most likely not. Just because a half thou feeler gauge is pretty weak. They're not real stiff to be able to shove into areas like that. So you can already see that what I'm doing is going to be a little more precise than what was machined in. Although I have the feeling I'm going to be here for quite a while. And I'm not really pushing down. This is a good heavy plate. I'm just letting it do the work. I'm just pulling it back and forth. Clean your paper every once in a while. Okay, I'm probably 10 minutes in total. Still on the same sheet of paper I started with, 120 to grit, just starting out. It's already shined up a lot. Just want to show you, like right there, you can still see there's some machining marks, and then it's smooth on both sides of it. Machining marks, smooth on the sides. Let's see, there's my machinist edge. I'm gonna focus in. There we go. I know you're looking at the block. I'm looking around the camera just to... what I'm looking for is light coming through from the other side, of which there isn't any. Alright guys, maybe you can see it better from this side, because if I come over from this direction, I get a lot of glare, so the surface is shining up pretty nice. I do want to point something out. It's called, it's actually a problem with the machining center, either the machining center or the block. The way they're holding the block isn't rigid enough, and it's like kind of like cutter bounce. It's as the cutter, you might not be able to see it here, but the arc is kind of going in this direction here. There's a big arc sort of swinging through here. I can just tell by the machining lines. So every time it hits a hole, as that cutter is coming through and hits that hole, it's gonna gonna sort of bounce real quick because it's got no load, and then bam, it hits material again. No load, bam, hits material again. And you can actually see it. Let's see if we can get the camera to focus. There we go. You can see over here, shiny and smooth. On this hole, you can see these lines rolling off this hole. I think there's grease on this little end pointer, but same here. See, it's shiny on either side, but on that hole, it's actually digging in. I call it bounce, but it's actually kind of digging in deeper. As you can see, this was higher. It's already sanded out. And this was higher, and this is actually deeper. Because what it is you've taken the load off of that cutter, because this block is actually pushing that tool up when it's cutting over here. When you're over here, there's no block to push it up. So just the weight and the momentum of that cutter allows it to cut deep for a little bit when it recontacts that material. So alright guys, I got this head done, or this deck for this one head done. It looks great. It is, as you can tell, very shiny. I still have a couple areas that didn't fully clean up. You can see right there on that water jacket. There's still some lines. Probably well within the 50 RA. So I'm not real worried about it. I still might just put a little bit of RTV there and just smooth it off with my finger. And there's a couple right here at this back. I really worked to clean all the ones around these cylinder sealing surfaces. There's still a couple fine ones. It's hard for the camera to even pick it up, right there on the edge of this wall. But I looked at the gasket. The fire ring compression boss, if you'll notice here on these gaskets, is way away from the edge, that raised embossment for the fire ring. It sits way back off that edge with these Felpros, so no worry there. And again, that's probably still within the RA requirement. So what I'm showing in this video, or what I've shown, is this deck still has to be done. Key numbers. This took me about 2 hours with 120 grit sandpaper. I actually went and picked up some 80 the other day. This is 3 or 4 days later from when I started the video. Picked up some 80, hit it with 80, and then re-120'd it just to get some of those last low spots out. You could probably even go 60, 80, 120. I think this is a 120 finish here. You could go to 150 if you're really shooting to go super smooth, but I don't think it's required. 120. A couple sheets of 120 will do it. I think I'm 4 sheets of 120 in. Granted, 3 were the first night. A partial sheet of 180 and a finish on 120. Actually, I use one of those. I reuse one of those other sheets of 120. So I've got 3 120s and an 80 in this deck here. And this was a pretty. These were some pretty deep marks. This was a pretty rough deck. I've already vacuumed everything out. You can see I just used oil rings to seal up the wall to the top of the piston there. Make sure no junk gets down in there. I sucked out all the. I had paper towel down in the oil passages, sucked out everything else. So good shape from a cleanliness aspect. Good, as you can see, you'll see in the video, this deck is better than what come off the machining surface. Number one, you can do things by hand better than the machining center, believe it or not. The key to that is having a good flat sanding block. Again, this is a machine surface here. You could use a piece of wood. You'll see some videos, I think, people using wood. Make sure it's really thick so that it won't distort as you're pressing on it, and get you an unflat surface that way. I use that and just weight, so I didn't even have to press down. I just weighted it up with steel so it uses its own weight. But I mean, you could take a piece of wood and take it to an edger or a planer and have it planed good and flat and use that. Because the key is, you're just using sandpaper. It's hard for sandpaper to take off significant amount of material. Again, I've got 2 hours just in sanding this one deck to get out surface variations that are maybe a couple thousandths of an inch deep. So you would really have to work hard to make this thing unflat if you're using a good flat block. I wouldn't use a soft block. Make sure your sanding block, whatever you're using, is hard. Again, this is almost like a lapping process. It will be better than anything you get from a machine shop. I don't care how new the machining center is. It doesn't matter, because to machine into steel, you have to have force. And what I'll show in that, you'll see in that video, is as that machining cutter sweeps across here, that machining cutter is having to press down here to cut. Well, now it's pressing down, there's nothing pressing back against it. So when it hits this wall right here, it's lower than it should be, and it will gouge deeper in this side if it's coming from this direction. If it's going the other direction, it'll be opposite. But anytime you cross a cavity, you lose that resistance to that machining tool. That machining tool will drop lower. It is imperceptible to the human eye. A profilometer can catch it, things like that. And on a better machining center, it would be minimized, but it will still be there. There still will be minor undulations that you can actually take out with a lapping / sanding process like I showed here. So hope you enjoyed the video. Hope you learned something. I was nervous about doing this. It's natural just to be nervous about things you've probably never done, but it's pretty easy. As long as you get a good flat block to sand with, you'll be in good shape. So hope you enjoy, like and subscribe.